Okay, so we're in 5-3, which will sort of naturally blend our way into 5-4. So we'll get two sections in today. First thing you'll have to know is how to do area of a triangle. So in your past times of math, you have done areas of triangles like this. Can somebody get me the area on this one figured out? It is 6. How do you do that?
Multiply like the two sides that have the make the right angle and then cut it in half.
Yeah, we go 3 times 4 is 12. We cut that in half. We come out with 6.
Okay.
So if we wanted to create a formula to do that, what would the area be for a triangle like that if we created a formula like this for it? Half AB. That would only work on right triangles. The other triangles you've done have been triangles where they would drop you in a thing called the altitude or the height. But if they want to do a triangle like this and not drop you anything in, we need a new formula. So that's what this is. To do the area, we're going to go half AB. Again, the little letters are for sides. Sine, big C, the big letters are for angles. What relationship would these guys have in terms of their positioning? The A and the B sides compared to the C angle. They're the sides that make the angle. So if this is side C, this is angle C. These are the sides of that angle. You could also call this angle the included angle for the sides. So you'd have different ways that you could grab them for a certain picture, but any two sides, you do the angle that's included angle. Question about the idea? Let me take a walk to the right, and we'll go to page 151, and we'll look at number 1. One homework problem for you, free of charge. So for number 1, they say there's a triangle ABC. You can label anything anywhere. So this could be, we're going ABC.
A.
A.
B. C.
C.
What page was this?
This is on 151, number 1.
Thank you.
They say side A is 5. Based on my drawing, that is the
Bottom.
bottom. They say side B is 9. That is the right. And they say angle C is 14. So that would go right there. Before you do the punch-in math, just make sure that you have the two sides that include the angle. You do. We're good to go. Just grab a calculator and punch some stuff. See how it goes.
Oh.
Everybody punched in.
Is that a 14?
It is a 14.
5.44.
Disagree. Unless the back of the book is wrong.
I also got a 5.44.
So you have, try this. Go 0.5 times 5 times 9
That's what I didn't know about
times sine 14.
5.44.
Oh, yep, it is. I'm sorry. I'm looking at the wrong place in the back of the book. You are correct. 5.443. That's a win. Yep, sorry. I was looking at 5.2's answer. Question there? Pretty easy?
Yeah.
That's why this isn't just a day to stand on. Okay, so the hard one will come in on 5. What would make 5 harder than 1 to 4?
You don't get an angle.
Say again?
They don't give you an angle.
They don't give you an angle. So before you can do anything on 5, you're going to have to get an angle. That's what you did last night. Last night you had some problems where there were 3 sides and you got an angle. That's what's going on there. There's 3 sides. Get an angle. Any one, doesn't matter. and then do the formula. Question about 151? Then I'll take a walk back over here to this empty space. I know this makes the test. What's the area formula? You would need to have that in your mind. I would ask you how this compares to this one. This formula only works in this formula that we wrote over here was only applicable for
Right triangles.
right triangles. Which again, like yesterday, right triangle means you have a 90-degree angle. If you try to do the sine of 90, when have you done that before?
On the chart.
On the chart. Chart says sine of 90, 1. 1 times stuff
Is stuff.
is stuff. Okay? So this formula, which you've known, it's just like a byproduct of this. This is like the main overriding formula that can do any triangle. The one that you know is just sort of a special case of that, where sine is a little bit friendly to B1. This turns into the law of sines. I suppose at some point somebody had this revelation that if you did A and B, you'd have to do the sine of C. What's another side pairing you can do other than A and B? What's a pair of sides?
B and C.
B and C. If you did B and C, you'd have to do the sine of A. A third way you could set up the area for any given triangle, other than A and B, other than B and C, A and C, in which case you'd have to do the sine of B. No matter which formula or which way you chose to do it, the results would all have to be the same. These have to equal each other. So I think somebody figured that out. Hey, I could do this 3 different ways. Those would have to be equal to each other. And then they looked for algebra ways to clean that up a little bit. What's an algebra thing you could do to clean this up a little bit to make it less scary? What do you like least about this?
1/2.
The halves. Is there a legal math way to abolish those halves?
Oh my god.
Yeah.
Subtract them all.
Disagree?
Multiply.
Multiply
2.
by 2. These halves are all trying to multiply. In algebra world, you always do the opposite. So instead of multiplying a half, if you divided a half, dividing a fraction flips it. If you multiplied by 2, those would be gone, and that would be a simpler looking equation at that point. You're still left with a whole lot of, what's it all doing though?
Multiply.
It's all multiplying. So you could clean up some more if you were willing to do some more dividing. You could divide everything by A and B and C. Here, if you divided by A, B, and C, you'd eliminate
A, B.
A and B, and you'd be left with sine of C over C. In this world, you'd get sine of A over A. And over here, you'd get the sine of B over B. And now I'll segue into the law of sines. Usually you'll see this in alphabetical order, and usually you'll see it with the sides on the top and the angles on the bottom. Something like side A over the sine of angle A equals side B over the sine of angle B equals side C over the angle sine of angle C. It's rare you'll see all 3 fractions happen at once. You're going to see something more of this style. If you see algebra something like that, what's your idea of how to battle something of this style? Fraction equals fraction, it's time to solve. Cross multiply is going to be a big star of the show for this section. What we need in our pictures, and I'll draw you a picture in a second, this law of sines is going to work only if you have opposites in your picture where you know both of them. So this could not have helped you yesterday. This did not apply to yesterday. We didn't try to do anything with this yesterday. Yesterday, what you had were some triangles where you knew two sides and an included angle. That's not a law of sines problem, because of these opposites, you know one. Of these opposites, you knew one. Of these opposites, you knew one. You never knew them both. Okay? For law of sines to be a workable thing, you need to have an opposite pair in your picture where they're both known. Not just both named, like X be one of the names yesterday happened, but they have to be known numbers. The other thing about this, and they won't ask you to do this yet, but this will come up later in the chapter, you can't use the law of sines to get angles unless you know in advance by logical powers that the angle you're working on would have to be acute. And we'll talk about that some other day, but that's a note to throw on there. I'm sure this note makes the test. I'm sure the formula makes the test. But someday they'll try to tempt you into using this to acquire angles. You can't do it unless there's a way to know for sure the angles are acute. But that's a conversation for more length of another day. So I'm on 153. 153, there's a number 1 that again says triangle ABC. You can label the letters wherever you want. So throw A
Up top,
up top. B can go.
to the left.
You guys are boring. You do it the same way every time. So ABC.
It's what we know.
They say measure angle A is 52. That's the angle at
The top.
the top. They say measure of angle B is 31.
The left.
It's the left. They say the side A is 8.
Bottom.
So I'm in business for law of sines because I have an opposite pair here where
Both are known.
both are known. And that's the kind of situation we have to have. We have to know both of these. If I step back to this question, would this be a law of sines kind of question? No, because 14 doesn't have a known friend, neither does 5, neither does 9. That would have to be more of a yesterday kind of law of cosines question. This, they want us to find side B, so I'll call that a B. They want us to find in a minute side C, so we'll call that side C. Your best bet when you set these up is throw the variable on the top. I would go probably the variable you want to go first position. So B goes on top of, what do you think? Who's B?
B. Sine B.
Which is sine
31.
31. The word sine will always go with the angles. That's not news. The trig word always goes with an angle. The side is just by itself. So B is across from 31. Put B on top of 31, but do the trig word sine with the 31. Then what's the other partnership? If B is going on top of sine 31, how can we complete that with 2 more known numbers?
A.
Which is
8.
8.
On top of sine 52.
Agreed. So we're going side on top of angle in the one pairing, so we need to do the side on top of the angle in the other pairing. We want this alone. You don't have to completely cross multiply every time. To get the B alone, since we put it in that position, the only thing you need to move is the sign to go with the top or bottom.
The top.
The top. So I'd punch 8 sine 31. The calculator forces you a set of parentheses to start before the 3, wrap it up after the 1 before you divide. So 8 sine 31, divide by sine 52. I'll take a peek to the back, and this time I'll actually look at the right section.
5.23. Sorry.
That's all right. I gotta sit there. Yeah, 5.23 is a win. Question about that? Are we done?
No.
No, what do we need?
C.
C. So go another go round. C should go on top of
Sine C,
sine C,
which we don't know.
which we don't know but can get. How can we get it?
52. Add the angles.
Add the angles, 83 so far.
180 minus 83.
180 minus 83,
97.
that's a 97. So C goes on top of sine 97. The same way that C, the 8, or the same way that C goes on top of sine 97, we can do who on top of who?
8 on top of sine 52.
Why is using 8 and 52 wiser than using the 5 and the 31?
Who's giving those to us?
Because they gave those to you. Those are for sure right. If you made a mistake on the 5 and you reuse it, it's just going to snowball out of control. To get the C alone, this just has to go up with the 8 again. And this is where you can use that second entry move on the calculator. Do second entry, just replace 31 with 97.
And
Calculator says 10.08. Any trouble with that? Here's an okay check. Biggest has to go with biggest. Smallest with smallest. That's an okay check. Here is a super check that can serve us well through the chapter. I'm going to grab my calculator and punch along with you. I'm going to punch in 3 things. So for one of them, I'm going to go 8 divided by sine 52. I get a decimal that really has no meaning? Yeah. 10.15? Anybody got it?
Mhm.
If I'm going to do 8 over sine 52, what do you think another pairing I'm going to do is?
10.08 over sine 97.
10.08 divided by sine 97. And my screen shows me 10.15. And that makes me feel, because those are the same. To be super good, I'd also like to punch in 5.23 divided by sine 31. Calculator says 10.15. Are they all identically the same? No, because the one went 10.152 versus 10.155 versus 10.154. The only reason they're not identically the same is because these two, what did we do when we wrote them down? We rounded a little bit. So there's not like total, absolute perfect agreement, but if we had used the fullness of that and the full answerness of that, they would have given you like complete agreement, but they're going to be about the same. And that's a more exacting check than the biggest thing. I would recommend on a quiz you do that. Like, we're headed toward a quiz someday where I give you 3 items, you give me back 3 items. You should know before you turn it in if you were right. If you do that little law of signs check and they're all agreeing with each other, you're right. There shouldn't be a big mystery like, I hope I got it right, I'll find out tomorrow. Like, you should be able to check those with that trick on the spot. 153, I don't think there was anything harder or different on that page. They're all the same. They'll give you 2 angles. You can always get the 3rd angle with 180 stuff. They'll give you 1 of the sides. You'll have 2 of these problems to do. You're going to finish the triangles today. They'll give you 3. You'll have to get the other 3. Question about law signs, areas, anything? We cut that, I suppose.